If we want to look at two binary numbers, which one is greater, or let's say if we want to look that A is B3, B2, B1, B0, so we want to look at A is greater than B situation, which condition will say that A is greater than B. So first, this is the most significant bit, these ones. So if A3 is greater than B3, then we don't need to test the rest because it's already A is greater than B. If A3 is equal to B3, then we need to test the second most significant bits, which one is greater and which one is less. So if A3 is equal to B3 and A2 is greater than B2, we can say A is greater than B. Similarly, these two are equal, then A1 is greater than B1 will result in A is greater than B. So if we look at the logic, so when A0 A3 is greater than B3, that means A3 is a 1 and B3 is a 0. That's the situation. So A3, B3. This one means A3 is a 1, B3 is a 0. This will result in a 1. This AND situation will result in a 1 because B3 is a 0, so B3 bar is a 1 and A3 is a 1, so ANDing them will result in a 0. So let's write the expression for A3 greater than B3. So if A3 is greater than B3, then A is greater than B. Or if A3 is equal to B3, that means that equality thing, so that I did in the last video. So E3, which we know that E3 is equal to A x nor A3 x nor B3. That's the situation. So A3 and B3 plus A3 bar and B3 bar. That's the thing. So A3 is equal to B3 and A2 is greater than B2. This also means that A is greater than B. Or E3, that means A3 is equal to B3, A2 is equal to B2 and A1 is greater than B1. This also means A is greater than B. Then finally E3, that means A3 is equal to B3, A2 is equal to B2, A1 is equal to B1 and A0 is greater than B0. This also means A is greater than B. So these are the conditions. This is the Boolean expression for A greater than B. Similarly, for A less than B will be just the opposite. So for A less than B, I won't make another separate video for this one. I will just do it here quickly. So A less than B, that means if we say A3 is less than B3, that means A3 is a 0 and B3 is a 1. Just the opposite. So this will result in this is, if A3 is a 0, this is a 1, 0 is becoming 1 here and 1 is staying 1, so AND is giving 1. So that's the thing. So A is less than B if A3 is less than B3, or A3 is equal to B3 but A2 is less than B2, or A3 is equal to B3, A2 is equal to B2 and A1 is less than B1, or just like before, these are equal. Finally A0 is less than B0. So this is the condition for A to be less than B, any of these. So this one or this one or this one or this one. So yeah, so I just have written the expression here. We'll do the rest part of the comparator circuit together later. I'm not drawing the circuitry anyway, but this is obvious that this is just AND gates with an inverter and then OR gates. So yeah, several AND gates and OR gates with inverters. We'll do this circuit.